we've been talking about the derivative up to this point as being a specific value, and of course it is. We talk about the derivative of a function f at a specific point a, such as at x equals 2, x equals 3, x equals 1, whatever it is. But what we also know is that the rules for finding the slope of the tangent line of a function can be well defined, which means we could actually find a function that we'll call f prime of x that we can simply plug in a different value of x and get the slope of the tangent line at that point x, so that we don't have to set up and evaluate the limit in every possible for every possible value of x. So the way we would do that is, let's go back to the original definition of the derivative, the one involving the h. And if we imagine that we have some point x here, and that I'm pointing to there, we have that point x, and we have and then we have a value h that indicates the distance between that and x plus h. So uh, h is just going to be the distance between these 2 points. What we have is just like before. We start with, except instead of a's, we have x now. So we start with the point x comma f of x right here. And if we move h units away from that, we end up with x plus h, f of x plus h. By simply evaluating this limit here, we can get a new function f prime of x that will give the slope of the tangent to f of x at an arbitrary value x. What I want to do is use that definition to find f prime of x for some function f of x, such as this one, f of x equals x cubed. So we're going to use the definition of the derivative to find the function f prime of x, and we're going to use the answer to find an equation of the tangent line at x equals -10. So what we want to do is we want to set up the expression for f prime of x by the definition. By definition, f prime of x, the function now, is equal to the limit as h approaches 0 of f of x plus h minus f of x over h. So that's going to equal the limit, in this case, as h approaches 0. We know what the function is. It's x cubed. That's going to give us x plus h cubed minus x cubed over h. Now, how do we expand x plus h cubed? I don't know if you remember this from algebra, but x plus y cubed is equal to x cubed plus 3x squared y plus 3xy squared plus y cubed. This is what's called the binomial theorem. Many people learn it through something called Pascal's triangle. I'm not going to go over that. I'm just going to tell you that that's the expansion, and you can figure out offline why that works. So this is going to equal the limit as h approaches 0. I'm going to expand that x plus h expression. That's x cubed plus 3x squared h plus 3xh squared plus h cubed. And then I still have to subtract the x cubed that appears at the end. So those first 4 terms are the expansion of x plus h cubed, and then I'm subtracting x cubed. So that all goes over h. Now, notice that the x cubes are just going to cancel out, leaving me with the limit as h approaches 0 of 3x squared h plus 3xh squared plus h cubed over h. What I can do is, since there's at least one factor of h in every portion of the numerator, I can simply cancel one factor of h and get rid of that denominator. So that's going to be the limit as h approaches 0 of 3x squared. Actually, there's going to be no denominator. 3x squared plus 3xh plus h squared. And by the way, keep in mind, the reason that I can do this, the reason I can just divide everything by h, is because as we're approaching 0, recall that the one value that we do not care about is h equals 0 itself. So this division that I just did by h is valid for all values other than 0, but even though h is approaching 0, it never gets there, so I don't care what happens at h equals 0. So this is going to be, now I'm ready to do substitution, so this is going to be 3x squared. There's nothing to substitute in this expression 3x squared. It's tempting just to say, well, x is the variable, let's replace it with 0, but h is the variable that's moving in the limit. X is, as far as that variable is concerned, is just a constant. When I substitute in h in the next part, I get 3x times 0, and then 0 squared. That, when the zeros cancel out, is just 3x squared. So the answer is that f prime of x is equal to 3x squared. And now I want to use that answer to find an equation of the tangent line at x equals -10. Well, let's see. So we know that f of negative 10 is going to equal negative 10 cubed, which equals negative 1,000. So the point of tangency is negative 10, negative 1,000, and the slope, which is going to be f prime of negative 10, is going to be 3 times negative 10 squared. Negative 10 squared is positive 100, so that's just going to be 300. So the slope equals 300, and an equation of the line is y minus negative 1,000 equals 300 x minus negative 10. I would accept that as an answer, but we might write it a little bit neater. It's y plus 1,000 equals 300 x plus 10. So there we go. So this is how you would find a derivative function, and this is how you would use it to find a tangent line.